Good afternoon, everyone. Myself Hari Krishnan. Uh, this is my second demo lecture for the part of faculty training program conducted by Physics Wala. So I got the topic to take the second demo is lenses. We all know it is in the plus two physics chapter. Actually, this chapter has two parts. First part is talking about mirrors, and second part is talking about lenses. So I'm going to start with lens. Before that, I want to know from students how many things you have studied about mirror. I hope everyone has studied about mirrors. So I'm starting with lenses, and first I'm asking what is the difference between or how images are forming in mirror as well as a lens. First, the topic is lenses. I hope this video and everything is clear to everyone. So, uh, how images is forming in lens and how image is formed by mirror. Yeah, in mirror, images are formed by reflection of light. We all know mirror has a curved surface. One part is polished, light is entering into that, then reflecting back, and image is forming. But in the case of lens, images are formed by refraction of light. Refraction of light. Lens is passing to from one medium to another medium. It is bending a path. Then one part is refracting, one part is reflecting. So in lenses, mainly image formation is happening by refraction of light. So, first, you in the mirror you have studied concave mirror, convex mirror, then plane mirror. So, like that, in lenses also we have different type of lenses: convex lens, concave lens, plano concave lens, plano convex lens, concavo convex lens. Like that, you are already familiar in the lower classes. This is a convex lens. This is a concave lens. You know the concave means the cave shape. It's a shape of cave. So we can remember like concave, convex. These are. So from here I'm trying to develop the definition of lens. What is the definition of a lens? The definition of a lens is a transparent refracting media. It's a transparent refracting media bounded by surface. At least there should be one curved surface for a lens. Yeah, you can see in concave lens, convex lens, there is at least one curved surface. So the definition of lens is it's a transparent refracting media bounded by surface, at least one surface. This is the basic definition of lens. So next, I would like to introduce some parameters regarding lens. Like you all are familiar with radius of curvature, then focus. Then I will ask how many focus are there for a lens and how many focus is there for a mirror. So like these questions are there. So first I am trying to explain what is radius of curvature, then focus, then optic center. Okay. Yeah. Then, what is the radius of curvature of a lens? You are all familiar with radius of curvature of mirror. So, I am asking what is the radius of curvature of lens? Yeah, this is a. I am taking example for a convex lens. This is my convex lens. What is radius of curvature? Assume that this lens, this is my first surface, this is my second surface. This is my first surface, this is my second surface. So So assume this first surface is a part of a big sphere. This. And this also, the second surface is a part of this. Okay? Second surface is a part of this. Then, this is the center. From the center to this surface, to the curved surface, this will be my radius of curvature of second surface. I would like to mention R2. Yeah, this second surface is also part of a big sphere. So, this will be the center of the first surface. Then this distance will be my radius of curvature of first surface. This is R1 and R2. So, this is all about radius of curvature. Same as mirror, we have some sign conventions like we are taking the measurement as a positive in the direction of light rays. The light rays are directing from x to minus x to plus x. Then the measurement taking along the light rays will be positive. If it is opposite of light rays, direction of light ray, then it will be negative. So this is all about radius of curvature. In this lens, if you are taking the light rays in this direction, this R1 will be positive, R2 will be negative. So second is focus. If it is one more focus is there, we will use plural sense. Plural, that is foci. So I'm asking a question. How many focus are there for a mirror? How many you have studied? You have studied mainly one focus. So, but in the case of lens, how many focus is there? There are two surfaces. Okay. Then how many focus will be there? Yeah, let's see how many focus is there. I'm taking example as this is my convex lens. So this is my optic axis or principal axis. For this lens, light rays are coming parallel to this axis. It is touching the first surface. Then it is refracting in the lens. After that, it passing through a point in the principal axis. If all light rays are passing like in this point, after refracting, it is converging to a point in the principal axis. This point is called, this is my focus, first focus. This is my first focus. This is my first focus. Then, what will be the second focus? Same lens. So, this is my principal axis. The light rays are emerging from a point. Light rays are emerging from a point after refraction through the lens. After refraction through the lens, it passing parallel to the principal axis. After refraction, it passing parallel to the principal axis. So, if that is a point we call as a second focus. This is a point we call second focus. First focus, light rays are coming parallel to the principal axis, then converging to a point. In the second focus, light rays are emerging from a point after refraction, it is passing parallel to the principal axis. This is called second focus. Like this, in the concave lens also, we can obtain two focuses. I am not drawing this right now. One focus will be this left side of the lens. One focus will be right side of the lens. To reduce the length of video, I am just skipping the concave part. In the classroom, obviously, we will discuss for all ray diagrams, everything we will discuss in the classroom. So for the time being, I'm just skipping. I'm just only dealing with the convex lens. So the next point I want to introduce what is optic center. In many textbooks, I have seen optic center as a center of lens. There will be a small correction. Optic center will be the center of lens only if the lens is thin. Obviously, in the plus 2 textbook, we are dealing with only thin lenses. All the problems are we are dealing with thin lenses. But actually, what is optic center? Actually, there's a definition type question in the previous year question paper of JE regarding the optic center. So, optic center is when the light rays are passing through the lens. Light rays are passing through the lens. After refracting through the lens, the emergent ray become parallel to the incident ray. Then if there is a point like then the light rays are meeting on the principal axis. That point is the optic center. I think you are confused now. I will explain. Light rays are emerging into the light rays are coming into the lens. After refracting, it passing parallel to the incident ray. Light rays are coming after refracting, passing parallel to the incident ray. I'm not saying exactly in the direction, but parallel to the incident rays. Parallel to the incident rays. Then the light rays are making a point of contact with the optical axis. Light rays are making a point of contact with the optical axis. That point is the optic center. I will give the diagram. Then I hope you guys will understand. This is my principal axis. Light rays are coming in this direction. This is my light rays direction. After refracting, from the first surface it is refracting. After refracting also, it is passing parallel to the light rays. Parallel to the light rays. This is a parallel. This is also a parallel. Okay. Then the point in which the light rays are making a point of contact with the principal axis. This is the optic center. This is the optic center. I hope now it is clear. Light rays are coming, and after refraction, light rays are passing parallel to the incident rays. Then the point at which the light rays are making a point of contact with optic axis, principal axis. This is called optic center. So then this is the actual definition. Then we are using the reduced definition. I told in many textbooks you can see it is a exact center of the lens. How it is coming. So I'm going to a short form or a reduction of this this property or this definition. For that, I'm going to measure. This is a parallel lens, but there is a shift, apparent shift. What will be the shift? This is the actual incident ray. After refracting, it is passing parallel to the refracted ray. So this is the path. This is x. X is the shift. So the definition of x we already studied in the refraction part. X is what will be the x? X is t into sin I minus sin r, sin of I minus r divided by cos r. It is nothing but thickness of the lens. This is the thickness. This thickness of the lens. X is the t into sin I minus sin r divided by cos r. This is the thickness of the lens. So, for a thin lens means thickness is tending to 0. See the equation. Thickness will tending to 0. Then obviously it will also tend to 0. That is, these two rays are exactly parallel. Okay. If the two trajectories are, this x is 0, then the two trajectories are same line of trajectory. Then the point will be the center of the lens. It is a small thickness, then it will be center of the lens. That is a reduced definition we are seeing in many textbooks. Today there is one definition type question regarding this optics, and that's why I included uh, for some time for this. So this is all about the basic parameters. I'm just introducing some important topic for the demo lecture. So there is all ray diagrams for finding the images at different points of lens, focus, between the focus and 2f, and beyond 2f, where the images is forming after refraction. There are many actually 4 or 5 table is there. I just now, for the time being, I am skipping that right now. Later on we will discuss, or in the next demo or in the classroom we will discuss. But for an introduction, I will say there are actually we need to some rules are there for drawing the ray diagram. First rule, the lens, the principal axis. The light rays are coming from infinity or parallel to the principal axis. After refracting, it will converge to a focus. It will pass through focus. And the second rule, the light rays are passing through the optic center. It will go undeviated, the path. It will go like this. These two rules are enough for finding the image ray diagram, position of image from the ray diagram. So some for 2 lens, for 8 something 10, about around 10 diagrams are there. For the time being, I am skipping the part right now. I am directly going into the lens formula, lens makers formula, then magnification formula. Then that one more important topic is the velocity of images. Okay, suppose object is moving, lens is moving, what will be the how the images will deviate. That is our main part I am going to cover today. So I am going directly into the part of lens formula. We have studied a mirror formula. Same as that, we have lens formula. Only difference is a sign. The lens formula, 1 by V minus 1 by U is 1 by F. Same as mirror, V is the distance from image, U is the distance from object. Sign convention as per same rule as mirror. There is nothing to discuss about this. You are already familiar with mirrors. So the second, lens makers formula. What is the specialty of lens makers formula? Then I am asking, is that focal length of a lens is constant or not? Okay, let's stop the discussion. After studying the equation, actually there is a derivation for this. Now I am skipping that. So I am going to the entrance oriented part. So coaching field, we are just discussing the equation and importance of that equations. So I am taking the whole board to explain lens makers formula. It is important topic. Lens makers formula. Lens makers formula, I am just giving that 1 by F. Left side of the part is 1 by F. N2 by N1. You are familiar with what is N2 and N1. N is denoting refractive index. So N2 is the refracting index of the lens material. N1 is the refracting index of the surrounding medium. So N2 by N1 minus 1 1 by r1 minus 1 by r2. 1 by r1 and r2 are the radius of curvature. That's why I introduced what is radius of curvature, focus, optic center, etc. So now I am giving asking the question: is that focal length is a constant every time? I will say focal length is a constant for a given pair of media. For a same lens, radius of curvature is nothing is changing. Then, for a given pair of media, we can assume that focal length will be the constant. Say, but if the medium is changing, surrounding medium is changing, then focal length will change. That is the beauty of this equation. See, this is N2, this is N1, refracting index of the lens by refracting index of the surroundings. So, if N1 is larger, this will be the negative quantity. The whole system will be, the focal length will be negative. If N1 is changing, suppose we are first we are studying a lens in the air, then we find a focal length. After that, you introducing into the lens into a liquid of different refractive index. For lens, for air, we are taking standard as refractive index is 1. For liquid, there are different kind of kerosene, water, different kind of liquids. Uh, Refractive index will be different. So the focal length is changed. So I am making a statement for a given pair of media, we can assume focal length is constant. This is lens maker's formula. Then I will give the equation for magnification. There are two types of magnification we have already studied in the mirror part. One is lateral magnification. Lateral magnification. So the lateral magnification equation M, obviously it is how long the image become diminished or it is become exaggerated. So size of image, I am denoting I image, size of object. After some substitution and everything, we will get V by U, image distance by object distance. Then one more reduced formula is there, F by F plus U. These equations are important. So one is there, we can find magnification, then we can go to lens formula, lens maker's formula. We can study all about the lens part. So if you have these 3-4 equations. So lateral magnification M is image by object, that is V by U, then F by F plus U. Then one more magnification term is there, that is lateral magnification. Sorry, this is lateral magnification. One more is there, longitudinal magnification. Longitudinal magnification. Longitudinal magnification. So longitudinal magnification is defined as M longitudinal is dV by du. This dV by du. This is not velocity. This is image distance with respect to object distance. So it is longitudinal. That is, we will get V by U the whole square. That is, comparing with lateral magnification, it is M square. Then we can say F by F plus U the whole square. This is all about this formula: lens formula, lens maker's formula, lateral magnification, longitudinal magnification. Lateral magnification, how much image is exaggerate or diminish, that is image height by object distance, that we will get v by u, then f by f plus u. Then longitudinal magnification, how much longitudinal it is magnified, how far, how long, then how much the image size is uh, changed in the longitudinal direction or lateral direction, that is dv by du, v by u the whole square, m square, f by f plus u, etc. f by f plus u the whole square. So this formula is sufficient for solving the problems or understanding the concept. All these equations, this f, u, all sign conventions as per mirror that take in the direction of light as positive or negative. That is. Then I am going to discuss velocity of image and object. It's a very nice, interesting topic. So I'll discuss with velocity of images. In the velocity of image part, there are different kind of cases. Lens is moving horizontally, object is moving. Then object is moving vertically. How the image will change? Two type of case. So first I am discussing velocity of image, that is longitudinal. We have longitudinal and lateral. So longitudinal in the direction of x direction. So sorry, the longitudinal velocity or moving in the velocity of images. Velocity, it is, I think it is not clear. Velocity of image problem. Velocity of image problem. So we have that longitudinal equation. We have the longitudinal equation, that is dv by du is f by f plus u the whole square. This is longitudinal direction, x direction. So I can rearrange I can shift du to here, then divide by dt, that is dv by dt is f by f plus u the whole square into du by dt. I hope this is clear. This dv by dt, this v is not velocity, this is a dimension of length, that is image distance with respect to time changing, that is image velocity this is du by dt, object velocity. This image velocity and object velocity is defined by constant f by f plus u the whole square. In a problem, you have given object is moving this speed, then find the velocity of image, etc. But remember one thing. This whole velocity terms, that image velocity, object velocity, we are obtaining in lens frame with respect to lens. While solving the problem, first we have to look the problem in the frame of lens. Maybe it is given as ground frame. We will change that to with respect to lens frame. Lens is moving. Then after solving the problem, options will be in the answers will be in the ground frame mode. So we have to change into ground reference. That is the thing. This all velocity terms are with respect to lenses. So this is first equation. Then second one, I can take like lateral magnification. M is V by U is F by F plus U. Here I can change U here, this and dt. This is yi by yu. This is a basic definition. Magnification. How much you measure is. So yeah, I'm taking these two parts. Then dy by dt is f by f plus u into du by dy not by dt. I hope it is okay. I hope everyone can get this equation from these two. This yi by t means the y-axis. Object is moving in the y, along the y direction. Then how images is moving in the direction. Okay? I hope it's okay. Yeah. yi by vt, f by f plus u, yi by yt. This is object is moving in the y direction. This is velocity of image in the y direction. Okay, this is all about the theory part. I mean, for the demo purpose. So now I trying to introduce some problem regarding the concept of this velocity image. I hope in the one problem you all guys will get the concept of this, how the frame can change, how. Okay. So a convex lens. I have a convex lens. This is my convex lens. Focal length of 20 centimeter. Focal length 20 centimeter. Object distance u is 30 centimeter. I'm not writing the question. I'm saying the question. I hope you guys also following this. Suppose object is moving. This is my object. Object is moving 10 meter per second in the x direction and 5 meter per second in the y direction. 5 meter per second. And I am introducing one more thing. The lens is moving. Lens is moving with the speed of 2 meter per second. These all are given in the ground frame. I am saying the question one more. Suppose we have a convex lens of focal length 20 centimeter and object is at a distance while we are observing the problem at 30 centimeter. Okay, 30 centimeter. So our object is moving with respect to speed of 10 meter per second in the x direction. Also, the object is moving in the direction of y with respect to 5 meter per second. Also, our lens is moving in 2 meter per second. This is a problem. I hope you guys are clear. So, the first thing in our mind should come all the problem, or in this type of problem, all the velocity should taken in the frame of lens. Here the lens is moving, so I have to relate this velocity with respect to lens. How? This is a relative velocity concept. So how to make in the lens frame easily? Lens are only in this direction of x. Okay, so for relative concept I can for relative we will take we will just reverse the velocity of with respect to what we want. We will just reverse the velocity of with respect to what we want. Okay, so we want with respect to lens, we are just reversing. Then actually this frame will become rest. So this from this lens I can observe the problem. From the lens, first lens was moving, then I am giving a negative velocity so that lens will become rest. Then the from lens frame I am receiving, then I am seeing the object. Object is appearing this two reversing, then it is giving this object is appearing with respect to speed of 8 meter per second. Okay, so this is 10, this 2 here, this is my object, this 2 meter per second, this is 10, this is obviously 5 because there is no relative motion with respect to lens. Lens is moving only in the x direction. So this resultant velocity 8 meter per second in this direction, obviously 5 meter per second in the y direction. It's okay. Okay, then I am going to find the image velocity using this equation, like dv by dt f by f plus u the whole square into du by dt. I think all parameters are given. dv by dt we have to find what is image velocity. Object velocity is given. We are taking the x direction for this. This is a equation for horizontal motion. Okay, longitudinal motion. Okay, so dv by dt we have to find. If is given 20, 20. What is u? This is focal length of second focus. Okay, most of the problems the focal length is for a convex lens. It is giving the focal length here, second focus. So obviously most of the case focal length will be positive, or else it will mention. If it is first focus, it will mention. Focal length will be positive. Okay. Yeah. What is u? Is that u is positive or negative? Yeah, you guys are extra confident. It is negative. So minus 30. The whole square into du by dt. What is object velocity? Object velocity du by dt, that is our new velocity 8 meter per second. Solve this. So you can check if the equation is wrong. This all dimension of length, it will cancel each other. It is a dimensionless. Du by dt velocity in the left side and right side, it is velocity part, velocity type. So equation dimensionally it is valid. You can use this in the first chapter. 20 minus 30 minus 10 and minus 10 cancel 2 minus 2 the whole square 4. So 8 into 4 32. 32 meter per second. Sorry, centimeter per second. So sorry, these all velocities are in centimeter per second, or else I had to change the dimension. Centimeter per second, all in centimeter per second. So it is centimeter per second. Okay, or else I have to convert. I think for okay, it's conversion also it will cancel, no problem. So that is 32. Okay. So first part is over. We have find the velocity, how velocity will move, how the velocity of image in the x direction. Then I am going to the second case. In the second case also, this velocity is with respect to lens, because lens not having a relative motion in the y direction. Okay, so this equation, we are taking this equation along the y-axis. dy by dt is dt. This is we have to find. This is 20 by divided by dt is given 5. So minus 2, this is minus 10. So this image is moving opposite to object. Suppose object is moving above top, image will move down.